So basically, we are going to try to recreate the interview that Shweta had last week, right? We'll try to understand how I would personally solve the interview. So let's start, right, Shweta? Could you tell me a bit about the interview that you had?
Yeah. So one second.
Okay. Uh, okay.
Okay. Yeah. So I had an interview last week. Okay, and they were more interested on the architecture part. First, they started with JavaScript. Like I work in Node.js,
Okay.
so they were interested in which type of application Node.js is good for, and what is the benefit of using Node.js. So when it comes to scalability and all these designing level words,
Yeah,
then
just
they
a minute.
hopped on to.
Yeah, I'll just write. I'll just keep writing as you speak, and then we'll decide on what was the way to have done it. So you're saying Node.js? What? Hello.
Yeah, like what all applications should be recommended using Node.js,
Okay. Should be
and what is the benefit of using Node.js?
recommended in Node.js. What is benefit of using Node.js? Benefit over what?
Like, what is the advantages of using Node.js for web applications?
Okay, so
I mean, why Node.js?
okay, so like benefit wise, right? So I'll tell you, we have Golang that is used if you are. Why are people joining so late? Yeah. Okay. So let's talk about it. What all applications should be recommended in Node.js, right? So in my practical experience, right, that what I've seen, like I've worked at different companies. Okay, why? Okay. I don't think there should be anyone else joining. But okay, in my personal experience, right, what all applications should be recommended in Node.js? Basically, whenever any startup that I've worked with that has gone from 0 to 1, right, they all start with Node.js. Okay. Like almost all, I've never seen a startup that says that, hey, we'll start our server with Golang, or some other language. They almost like 90% of startups start with Node.js, and I'll tell you why. First is package compatibility, right? How do I say? Yeah, package compatibility. Like if you have looked at AWS, right? AWS you have seen, AWS has various packages, right? They have packages in Golang, they have packages in Node.js, they have packages in Bash, Curl, JavaScript, right? What is the best package that you think AWS has? For like, which package has every all kinds of support, right? Like let's just say you want to if you look into AWS in deep, right, you will see that there are certain functions, right? So there is CLI, AWS CLI, that has support for everything, all language, right? But after CLI, like there is some IAM rewrite role or something, you will see that the Golang package does not have that, right? That function is missing in the Golang package. They will update it, but it's not there, right? So any company, whenever it has to expose its packages, or it has to expose a package to the outside world, it's going to expose a Node.js package. That is the first advantage of having something like Node.js, right? um, and that's one of the reasons most startups do it. Another reason is basically because JavaScript is a pretty old language, right? And there are a lot of JavaScript developers out there, right? So when you're building a startup, these are things that you need to think of, right? You A JavaScript developer can do both the front end and the back end, right? So that's one more reason, right? But if you actually ask me, right, in terms of performance, Node.js is kind of inferior in almost every aspect, Literally, if you want to build the best application, you don't build it in Node.js. That's why when you build it in Node.js, you later move it to Golang or something. Like, I'm not sure, Shweta, if you know something like Bun. You know this? Hello? Hello?
No, no, I'm not aware about it.
Yeah. So you just
Hello?
keep your you just keep your mic on, so we'll have like a dual way communication, right? So Bun is something that was recently invented, right? And I'm gonna tell you about this, right? This is a JavaScript library, not library, sorry. This is an alternative to Node.js, right? JavaScript runtime, it's called, right? And this is significantly faster than Node.js. See how Node.js is 14K and this is 71. This is how fast it is. It compiles TypeScript on the go, right? In Node.js, you have to compile TypeScript to JavaScript and then execute. Bun compiles TypeScript directly. It's like, Node.js on steroid. You use this, you won't go back to Node.js again. So see, that's why we say that Node.js is. Okay, your dogs are barking too much. Yeah, so that's why we say that Node.js is. Um, but again, I hope. Okay, okay. So that's one of the reasons, right? We don't use Node. That's one of the benefits of Node.js. Like, I hope this line is very clear, right? Package compatibility, the fact that it's kind of a default language because of how old it is, right? And if you ask me, what is one reason where Node.js outshines any other language like Golang and all? File IO, right? File IO node, like JavaScript is basically a very good language for any kinds of file IO stuff, right? Because it's single threaded in nature, it can handle those kinds of processes much more conveniently, right? Just like Golang is very much good for if you have short term, short, like small jobs that are running, right? You can spin up hundreds of Go routines and have them superimpose on a small storage and have that, that works really well for Golang, right? Fast execution. So this is an answer to the question that you faced in, I think, first question. Can we move on to the next question? What else did the interviewer ask? Hello? Hello?
Hello? Am I
Yeah,
audible?
you're audible. So I had to mute you because there was some barking coming on. But yeah, so I hope this question is clear to you, right? Like
Yes,
how
yes.
you would have. So what did you answer exactly when this question came on? That what application should be recommended? What is the benefit of Node.js?
I answer because Node.js support asynchronous facility very well because it's a event-driven programming. It's a event-driven having architecture, and
What do
I
you
think
mean?
so. It is good for web applications.
Okay. What is event-driven architecture? Do you know?
So basically, everything inside, yeah. So event-driven architecture is facilitated by event loop inside Node.js, and
Event.
like every IO operation. Okay.
Yeah. Okay. You're doing good. Yeah. Tell me.
Yeah, so every IO operation inside Node.js is considered as an event, whether it is a timer event or whether it's a input output event, and
Okay.
accordingly there are queues to handle it. Okay, and it will the so queues has priorities. So according to the priority of the event, it will go inside a specific queue, and then it will get executed inside a call stack. So JavaScript has a very beautiful execution way of executing way, like it execute everything in a call stack. So that call stack is never blocked, and it also facilitate multi-threading concept. Facility. If you have high CPU intensive tasks, then you can create lot of worker threads, and you can delegate those tasks to those worker threads.
Yeah.
So there are these benefits in JavaScript.
Okay. So I would actually say it's not a benefit in JavaScript because JavaScript is not multi-threaded in nature. It's basically single-threaded in nature. But if you have high
Yes,
CPU
yes.
intensive tasks, right? Like I just said, file IO, JavaScript is a good language because of it being single threaded in nature. Um, but again, like as long as you are able to justify what you are saying, right? So we'll move on to from this question, right? So what was the next question that you got?
Yeah, so when I answered this part, that it can be, useful for scalability, then the next question was, he asked me to make a simple high level design of Amazon like service.
Okay.
So then I started with the flow, like how we start in Amazon and what is the flow, like login, then ordering, and then place payment. Every flow I thought in my mind, and I gave him some five microservices list,
Okay.
uh, which was user, product, notification, vendor, and payment.
Okay, let me think of it, right? I'll try to solve this high level design of something like Amazon, right? I think we have discussed similar services. And so this is a user, right? From what I can think of it, this is a user, and let's just say he has his phone, right? Okay, and he opens up Amazon, right? So there's front end, this is the basic mobile app, he's opening up Amazon on his device. And how does this and this connects to Amazon, right? So we are going to define a few microservices that basically Amazon is going to use, right? So the first thing that I'm thinking of, and this is something that we have thought of multiple times. I'll just mute you again. Yeah. So yeah, the first thing is basically user service. This is something we have talked about. Like we have just a minute. Service. Okay, server. Yeah, like this one. Okay, so let's first try to define all the services, right? This is a user service that we will have, right? So this will handle all the how do I say, all the user login, sign-ups, and all that stuff, right? uh, like we already covered this. Just give me a minute. Yeah, sorry. So let's so the user logs into Amazon, and then he gets this user service. And then what are the other services I can think of? So I can have something like what am I thinking of? Let me see. Let's see. User service, then product service for listing all the products, right? Search service for searching products. Basically it has hundreds of microservices, if you think of it, right? You're doing a lot, like it's operating at the scale of Amazon. So you have products that are listing all the products. And again, vendor service is something I can think of. So this service is where all the vendors are going to go to get their products listed. And right now I'm just thinking out loud, I'm not even starting on the system design. Like we will try to understand how to tie these things up together once we once we are done building these microservices in our head, right? User service, product service, vendor service, search service, vendor services twice. um, so the user comes to Amazon, he opens up Amazon, he searches, and then there's vendors that register, the payment service, right? Amazon sends out a lot of notifications, notification service. Okay. The thing is that I can keep doing this all day. Like I could keep building hundreds of microservices, but I don't want to do that. I want to build 5, 6, 7, and then try to explain them as best as I can, right? So then there's notification. Let's see what all I've covered: user service, product service, finally analytics service. Okay, so these are all the services that I can think of. I mean, I can think of a lot more, but I'm not thinking. 7 is a good number, and then we are going to go deep into each and every of these services, and I expect that you guys will be able to answer some of this, right? So Shweta, I muted you. Can you unmute yourself and tell me that which of these services are common, right? Something that we have already discussed about. Which one of these services?
User notification, analytics, and search.
Exactly. So you know how search service is built, right? We use Elasticsearch, right? We
Right.
just ingest it into Elasticsearch. It's
Yes.
basically
Yes.
it does a lot of things, right? Elasticsearch is configured in a way that you can build layers on top of it. So based on nationality, if you're filtering out, right? So internally you would define all that. Like if I'm a user in India, right, and I'm searching, I should mostly get Indian products. But if you look at Amazon, if you look at the behavior of Amazon, sometimes you will also see foreign products. So the search service contains all the data, but it's basically not really going to search into Amazon UK unless it needs to, right? So that's search service, analytics service, and then we have payment service, vendor service. I think your dog is barking too much. I'm here to hear that. Yeah. So this payment service, and okay, now I want to go into more detail into each of these services, right? Trying to understand. So this is a user. He comes to the page, right, and he logs in. He gets the token back, and then there is this product service, which is basically used for fetching. It keeps a list of all products, right? Let me just write it here. It's basically list of all products is what I can think of right now, right? The notification service is used for sending emails, SMS, and OTPs and stuff like that. The payment service is what I can think of. So let's try to trace out a user journey, right? User journey. If I am to do this, that's a more convenient way of understanding. Okay, so first the user comes to user service. User comes to user service to register, right? There are multiple stages in this journey actually, right? Then okay, one more service. Okay, recommendation service. Okay, so
So,
then
Pradeep,
yeah.
do we need to have a separate recommendation service? I mean,
Yeah,
this functionality cannot be included in product service only.
product service basically contains a list of the products, right? Recommendation service is specific to specific users, right? So when you talk about, let's try to dissect some of the features of the product service, or what I'm thinking of, right? A product service is in no way related to a user. It's more related to the vendor side of things, right? So it contains all the details of the product, who the vendors are, the geographic location of the product, right? It might also contain the details of like let me think of it. It might also contain the details of what how many products we are like shipping and stuff, but they also can go into the analytics service. So I can I'm gonna think this product service as a very simple thing. It just contains a list of all products, and it just exposes an API where let's think of it, if you want, you can extend it, right? So what does a product contain? A product contains metadata, right, which is the id, name, and it contains images, right? Product has images, so this product service might also figure out how to redistribute these images, right? We already discussed this, right? CDN. See, everything comes together, right?
Yes, yes.
Everything comes together, everything we discussed. CDN, right? So this service already has enough responsibility in itself. It does not need to be concerned about any other service. This is something that is tied to the user service, if you think of it, right? And why I'm not putting it in the user service in itself is because it has machine learning algorithms in place, right? There are complicated ML algorithms. It's also not just reading from the user, it's also looking at trends, right? Like today this product went viral on Instagram, why don't I recommend it to a lot of people? That's going to give him a pattern. It's going to read from ads, right, that the other user has. Just think of it, all the sources that this user, like you're scrolling through Facebook, and you liked a certain thing, right? And that was a paid ad, so that information backfed into Amazon, right? They have their again, I'm not writing that microservice, but there can be add microservice that's getting all this information, and then that pulls into the recommendation service. So recommendation service will be like, let me show you this so that you will immediately purchase it because you just liked it on Facebook, right? So just try to understand how complicated this service is, right? Because it's feeding data from a lot of places. It's also taking into the feeding from the user service, but it's feeding from a lot of other services as well, right? And there are a lot of algorithms in here, right? So user comes to user service, user goes to the recommendation service, right? He gets the list of recommended products, right? And recommendation service feeds from a lot of these services, right? And then let's think of it. Okay, notification service comes in place in the middle. User comes to user service, he gets notifications from the notification service, right? OTP, SMS, whatever. He goes to the recommendation service, and then he recommendation service hits the product service, it fetches the products and it displays him beautifully, right? And then if he has to search something, he goes to the search service, right? Elasticsearch, we already discussed. I'm still gonna write it down because I think we have new people coming in. Yeah.
Ramit, I have one more question.
Yeah, tell me.
So in this search service is related to product, right? Whatever product user will search, that he and she will get to see.
Yeah.
And product is already organized according to the location,
Yeah.
region, whatever it is. So we why we need to have a separate search service? I
Yeah,
mean,
like, do you
what's
search a product by
the
its
reason?
UUID in Amazon?
No, no, like just the
Yeah, so I mean,
name or category.
yeah, I mean that's a basic question, right? You don't search it by its UUID, right? Why do we need a DNS? Why do we need Google, right? You can just use the DNS, right? Okay. Like, do you know what the DNS of Google
Okay.
is?
DNS, I mean, delivery network service.
No, no, no. Sorry,
It
sorry, sorry,
is
sorry, sorry. Really sorry. What's the IP address of Google? Google.com. Like it's 4.4.4.4 something, right? So very few people know it, right? But everyone knows google.com. So that's so you know why you need a search service is because of the very simple reason, right? Because people don't search by UUIDs, right? People search by random terms, and I think this was explained multiple times that search service is basically used, right? Elasticsearch is basically takes in large quantities of JSON data, right? Billions and billions of that JSON data goes in, right? I think I have an entire video on this on Elasticsearch. I would really want you to go read that today, right, once this session is done. But Elasticsearch is takes in huge quantity of JSON data, and you can search by any term, right? Elasticsearch gives you the closest results, right? Not just Elasticsearch, you have things like Algolia and stuff that also works to make smart searches, right? Which is how people searches in natural language, right? You don't search in SQL or something like that, right? So that's one of the reasons why we have search service in almost anything, any service you have search service. And I want you to really read that. Okay. But yeah, let's go over any other questions that you have. Hello. Yeah. Is your mic not working? Okay. Tell me what other questions were asked to you during the interview, right? Let's go there.
Okay, so the third question was that for which all purpose notification can is used. When I mentioned in notification service, then he asked for which all purpose you are using notification service.
Okay.
So my
So
answer was order placement,
okay.
packed, shipping, and delivered. OTP for payment, OTP for password change, OTP for login,
Okay. So I would just say
and
anytime you
sending emails.
yeah, yeah, yeah. So that's a great answer. I would personally just say that anytime you need to send a notification, SMS, email, PN, could be anything like user OTP, whatever. Is use notification service, right? So what was the follow up question?
Okay, so the follow-up question was that, I mean, what you will use for notification service, like whether
Okay.
you will use DB or a message queue.
Okay.
So as I was familiar with Kafka, so I have said Kafka.
Okay. But how can you build a notification service with just message queue, right? We'll dissect this, right? I think this is a system design question in itself, right? So let's do notification service. I actually built this we built it as a team in Slice, right? So first we have a message queue, right? Okay, first try to understand what are the various components of a notification service, right? So we have SMTP third part providers, right? How do I say this? But are you familiar with something like Kalera? Do you know what Kalera is?
No,
Can you
no,
Google it? Can you Google it?
yeah, yeah.
Yeah, just Google it. And we have ACS, then we have Gupshup. Okay, okay, yeah, and then something like I'll draw some of the designs in the meanwhile, right? Look at it, right? There is a SQL database, then there is a just understand NoSQL database. Okay, this is weird, but okay, NoSQL database, right? Then there is analytics. Okay, let me just make it more simpler. Analytics service. As it backfeeds into it.
So I have just texted a basic definition of Kalira
Okay, you
in the
didn't need
chat
to text it
from
as long as
Google.
you know. I'll just tell you what Kalera is. Kalera is a provider that is used for sending SMS, right? So it's not possible for all of so it has ties in with the government of India, all those things, right? So whenever you have to send an SMS, you register with Kalera, they give you APIs. Using those APIs, you send SMS. Whenever you have to send email, you have provide SMTP providers like SES. You register with them, they give you, all of that. WhatsApp, we have something like Gupshup. These are billion-dollar companies, right? So expect you guys to have basic idea on this, right? And notification service comes a lot, so this is very important, right? SQL database, NoSQL database obviously backfeeds into the analytics service, right? Let me think of the architecture, right? We have a message queue. Let's just say we have Kafka. Okay. Queue, right? Okay, let's assume this is Kafka, right? Okay, so we have Kafka. So what happens is there is a service, right? Third party service. Let's just say third party service, and this service needs to send a SMS, email, WhatsApp, whatever, right? So it hits Kafka, right? And then in Kafka, if you know, there are these channels, right? Again, this is something I explained in depth in one other video, right? You have this like channels. How do I say channels? Like I'm just trying to explain, right? There are channels, and then there are Kafka brokers, right? So so you can create, let's say you create a channel which is for a very high priority message, you create one that is for lower priority message, and create one for the lowest priority, which is the marketing communication, right? You create a channel for the OTP SMS, you create one for the standard SMS, and then you create one for the marketing. So third party service wants to send something to notification service. Depending on the priority, it hits Kafka hits a notification service, right? And what the notification service does is, whichever service it wants to send to, it is going to basically send to, right? And the details are written down in the SQL database, right? And for analytics purposes, we are just going to store this analytics in the NoSQL database, and eventually this analytics service is basically going to be what do you say, it's basically going to be like Redshift, or some of the big data processing, right? So because there are billions of emails being done, so it's basically just going to process this data sequentially. NoSQL is just because if I have to query something, right, like if I have a 30 minutes downtime, right, in between, now I want to see what all happened, right, I can hit NoSQL, I can see that data sequentially, right? Because once it goes here, it's very difficult to retrieve the data. Here the data is parsed and stored, right? It's more used for processing the entire data as a whole and deciphering patterns from it. That's what analytics does, right? You cannot query from analytics because it's not stored in that format. It's stored for billions of, it's stored for finding patterns in data rather than finding particular details in data, right? Again, these things we have discussed a lot before, right? So when I think of it, right, how do I build, so whenever you are this is a bare bones implementation. What I can think of is, when we are trying to build, let's say we are trying to send a message, right? The message is not going to be very much different, right? Like if we are sending an OTP, right, there's something known as a template, right? And you can think of, right, Amazon sends you an OTP. That OTP is not different every time you place an order, right? Your order has been completed every time. It does not give you a custom made that some Amazon agent has handwritten it and hit that button and send it to you. It does not happen like that, right? So what happens is, first we register these templates with the notification service, and then they go into the SQL database and they are registered as templates, right? Then this third party service is basically just going to hit with the template ID. It's going to say, I need this template ID and I need this message to be sent, and then it's basically going to search in the SQL, and it's also going to hit with the parameters, right? So like, let's say Amazon is sending you a message, right? Hey, user ID, your transaction worth this has been completed. So it's basically stored in a template format. You can check out SES as templating support, you can see that how these templates look like. There's a dollar, like that, just like, you write strings, um, you write variables and then you put dollars in there, right? So it's like this template with parameters that it passes to Kafka. It's just going to go to the SQL, it's going to find out the message, it's going to hit Kalera, ICS, Gupshup, right? One more level deeper, right, if I have to go, right? um, let's think of it. How do I internally implement like retry logics and stuff like that? I can build campaigns, right? So campaigns are something that I can think of is pre-configured, right? Let's just say I'm sending a marketing campaign. It's going to be it's basically, why do we want to do campaigns? Because what happens is, when we have something like, template and parameters, everyone's gonna make their message a priority, right? So what we do is we register campaigns inside the system, and each campaign is said, let's just say this is an OTP campaign, right? So when you are registering an OTP campaign in your notification service, right, it goes in the database. So now you have eliminated the issue that, every third party service wants, like, every third party service wants its messages to go in a priority, right? Because the thing that happens with microservices is that you have microservice stakeholders, right? Like, you have 5 microservice, you have 5 managers, and every microservice stakeholder wants that whatever I want to send, it should go, even if, the other, if someone's OTP is stuck, that's the other microservice holder's problem, right? Because I want my email campaign to go, that rises my, that rises my metrics, that gives me a fat paycheck. So why should I give two shit about, this other person who is, who is trying to send an OTP to some user? That's another microservice, that's a stakeholder I don't care about. So that's why we built these things like campaigns, right? So what happens when this third party comes, we say first you registered a campaign, right? In that campaign you write down it's an OTP campaign, it's a, marketing campaign, and based on that we will give you the priority. We will tell you which Kafka queue you can put your message in, and then once you put your message in, you pass it to the notification service. Based on that we are going to process it, and then maybe we might also have, multiple, again, then if I go any further, it's going to go into the LLD zone, right? Because we might try to figure out how retry logic works, how these things will work, right? There are other things that, one more thing I have to tell you guys to figure out, right? So you need to be very careful when designing these kind of notification services, because what happens is, let's say this is Kalera, right? And Kalera has a server in India, right? And you are sending an SMS to some person. So India to India, right? India to Indian user, if you're sending a message from Kalera India to Kalera India, that charge will be 10 paisa or something like that, right? But from India to, let's say there's a Sri Lanka user or there's a US user, right? And you're hitting Kalera India and telling it to send him a request, right? That charge will be 10-15 rupees, right? So a pen tester might come and he might drain your company's funds like that by making dummy OTP calls to, let's just say, Kalera. Like, he takes a US number and he makes dummy calls to Kalera US, and he will drain your bank account like that, right? So there are a lot of these things that, you can take care of. Shweta, is this thing understood by you, or like, would you want me to go into detail about something?
No, no, I understood, but like 80%,
Okay.
as 20% still. I think
Yeah,
so. I have to
I
be. I
actually went
mean,
into
study.
a bit more detail because I've actually worked in this system. So some things you will not, obviously, if you have not worked, you won't know, right? Like this kind of fraud issues and other things. I've actually worked in this kind of system. But okay, like whatever, 80% is more than good enough for me, right? Just understand how microservices communicate and all. But let's see, what other questions did you have, like in the interview, right?
Yes. So he was. The next question was how you will be able to handle the load. Like if you have lot of notification.
Okay.
Suppose there is a sale time
Okay.
you have lot of notification to push, whether it is for payment or whether it is for order placement, how you are handling load in your message queue.
Okay.
That was the question.
Okay. And what did you say?
I said we can have, priority based topics, and for that we can have multiple replicas.
Yeah.
So priority based topics will have less load on the specific Kafka server.
Exactly, exactly. So, the major reason why we have Kafka is to handle the load, right? When we first built the notification service, we did not have Kafka. We just had it basically hitting the notification service. And then what happened was one day, our marketing team, they ran a mail, and our servers choked, right? So I'll tell you an interesting thing how this happens, right? If your server hits above 70-80% or 90-95% capacity, right, what happens is it turns unhealthy, and it starts dropping a certain number of requests. It starts giving you 4xx errors. And what happens when you get some 4xx errors is that your ECS, there's the health check that your target group does, right? So it starts perceiving that this system is faulty, right? That this container is faulty. It's not working, right? So what it does is it tries to spin down that container, right? It tries to shut down the container because it thinks it's faulty, right? And it tries to spin up a new container. And now what happens is when it's trying to spin down a container, the network load becomes even more. It hits the other containers that are running, and they start falling. So it's like a domino effect, right? Which is very dangerous. So that's why we had Kafka. And one of the ways that you can handle load is that basically you have these Kafka topics, right? So what you can do is you can see that how many messages are there at any point in the queue, right? And if there are too many messages that are accumulating in the queue, you start spinning up more and more and more containers, right? So if you can basically hook up a cron job to your Kafka, right? So it should and again, it's more of a stupid question because again, I don't really understand the architecture that you gave, because it's just a queue, right? um, but again, like, the purpose of having a Kafka is actually to handle load, right? But yeah, that's kind of my explanation, right?
Okay.
Yeah. So you can, what else did he ask?
So the next question was, if there is a delay in the notification for OTP for payment, which is very critical, then how we handle that thing?
Okay. Delay for OTP payment. mm, Firstly, OTPs are very critical, right? So, like, we always have enough containers running. We always make sure that even at peak times, right, there's not that much load, because when we talk about payments, right, and stuff like that, that's critical, right? But again, that does happen, right? A lot of times, if you're going on Amazon, if you're sending an OTP, it does not come, right? So it's not like it's foolproof, right? In a lot of cases, OTPs are dropped. And the way that OTPs are sent is that they have low TTL. What happens is, if you see, right, there's a situation where the user sends an OTP, right? Sends OTP stuck in Kafka, right? It's not processed, it stays in Kafka for 2-3 minutes. User resends OTP, right? It generates a different OTP. It's resent. This time this OTP is processed. Sorry, this time this OTP is also stuck in Kafka, and now the first OTP comes, right? And now invalid OTP, right? Invalid OTP. He again sends OTP, like he again requests OTP again. Second OTP comes, right? And then user smashes phone or something like that because of this experience, right? Right, so this kind of experience does not happen, right? So the reason this does not happen is because OTPs have a low TTL, right? So if an OTP is stuck in Kafka, in 2 minutes it will get invalidated by itself, and the second OTP might come, or the OTP does not come. Like you will see in situations where you have requested an OTP, it never comes, right? But in general cases, also in 90% cases, it's OTPs are very high priority. They are usually just sent out, right? Unless it's an issue with Kalera or your local SMTP provider. It's almost always like 99% of the time the issue is with your SMTP provider. The issue is with Geo that does not send you an OTP. It's not an issue with the system. Trust me, systems are very well built as compared to how Geo has built, right? But yeah, that's it, right? Tell me, what other questions did you get?
So yes, next question was: are we keeping same DB for all microservices? Like I mean, same MySQL DB or like same NoSQL DB for all microservices.
Completely depends on
So I
purpose.
said,
Yeah, yeah, you said.
okay. Uh, I said as it RDMS is good for relations, so product and vendor they can have RDMS. Search can sorry, not search. Then user can have NoSQL. So
Okay.
this way I told him.
Okay. The way I like to think of it is that each one of these microservices can have a SQL, NoSQL, uh, or both, right? But for things like payment service, like the architecture I can think of is it can be NoSQL also, it can be SQL also. I've seen payment architectures that are NoSQL and SQL, because when we think of it, right, payment service should, yeah, it's not a DBMS heavy thing, right? It's not a like database heavy kind of architecture, right? So there's not a lot of transactions that are happening, right? How many times do people pay, right? People are not paying money that much as they're scrolling and shit, right? So you can put it in a SQL, you can put it in a NoSQL, makes no difference. The data is not that much. Search service is Elasticsearch, right? Database also, you can have NoSQL for storing data, you can have SQL also, but from my implementation it's just basically Elasticsearch and some layering on top of Elasticsearch. Analytic services, not just NoSQL, but it's also things like Redshift and other big data analytics for figuring out patterns in the data, right? Trends in the data, right? Based on that, they do a lot of that shit, right? Vendor service, again, basic SQL, relational databases, user service, basic relational database, recommendation, again, a lot of these services are not limited to SQL or NoSQL, right? It's more based on the purpose that you want to solve, right? When you're going into DB design. But yeah, user service, vendor service, we can have relational. I think recommendation service could be a graph database. It's a good idea to have graph database. um, if you guys don't know, graph database is basically optimized for relations between data, right? So not tables, not rows, but let's just say this is a user A, right? And this is a user B, right? So find how many friends does this user A have or something like that, right? So it optimizes those relations, right? Find out users who have 6 friends, if you want to do this kind of queries. So graph databases optimize on that. So when you talk about something like recommendation service, graph database is very perfect for it. But again, it's better to stick to SQL and NoSQL, unless you have that high level understanding. But yeah, that's kind of about it, right? Any other questions that you had?
No, I think so. This was the last main question.
Okay. So how was like the interviewer feedback, when you reply or
So when he insisted me a lot in like how I will manage the load in Kafka server when there is a peak time or there is a lot of spike, then I was not getting this topic thing which he was expecting, but after 5 minutes, then I got like, okay, we can distribute it by a topic. So then he said okay.
okay, okay,
And then I think so. Then B was the next question, and he said, "Okay, I'm done."
okay, okay. Got it, got it. So I
And
think
then
this,
I think so
yeah.
that one more question was there
Okay,
related to that domino effect wala thing.
okay,
He wanted to know that like if any server is down, then how we are handling it. So same answer I have given to him, that
okay,
how we come to know that if a server is down. When I said there is a health check, I think so that is passed between two server and there is a wait time for it. So if one basically between load balancer and a server. So if load balancer doesn't get that health check response from a server within certain period of time, whatever has configured, then it will again wait for like maybe 10 more seconds. If still he doesn't get that response, then he will consider that server is not healthy and he will route all the requests to the rest of the server.
okay. So
But I have
yeah, yeah. So first thing is it's not load balancer. It's called target group. You can check that in AWS. And
okay.
so a target group registers various IP addresses across various availability zones, right? So like Mumbai, US, sorry, AP South 1, which is Mumbai, that is an availability zone. That is a zone where AWS has taken a farmland and they have put millions, hundreds of servers in there, right? So that's an AZ. And then there's one in, I think, Malad, or I think Mumbai, they have sorry, Mumbai is one, AP South 1, AP South 2. So load balancer just routes the traffic. Target group is basically something, load balancer goes to target group. Target group is basically that organizes and handles all these heartbeats and stuff like that, right? So it is target group, just remember it. And yeah, I already explained how that heartbeat thing is happening, right? If it's unhealthy, then the container is spun down, and the it tries to spin up a new container based on the instructions that the target has, right? Yeah.
Yeah, Ramit, I have a question, but you said
Okay.
that it will spin up a new container, but by the time the new container spin up, like it has to boot up and then it has to pass the health check and then it will be ready for taking requests, right?
Yeah.
Then other server also can get crashed. I mean, then there will be like lot of load in this kind of scenario.
Yeah. Yeah.
You
Exactly.
have
Yeah, you're saying.
you have gone through an engineering block where adaptive topic was there.
Yeah, adaptive
So
load shedding.
like if there is no assumption based any precaution, yeah, then this we can actually have a severe downtime, right?
We don't have downtimes like that. So, firstly, if we went through adaptive load shedding, right? Um, it's a very basic concept that we went through, right? What is the difference between static load shedding? It's basically that if you have a traffic that's going like this, right? Like if you have traffic that's, sorry, if you have traffic that's going like this, static load shedding is basically you plan for this, right? That at this time I'm going to scale up my server, at this time this is 1 p.m., this is 2 p.m., I'll scale up again, scale down at 3 p.m., scale up, scale down, like you do these things, right? But you don't configure anything. Adaptive load shedding is when you hit here, right? Your servers are at 70%, you keep spinning up new containers. If you hit here, right, you spin down. So it's nothing is configured in adaptive load shedding, right? Downtime is a weird thing because when you're using something like Kafka, right? So the purpose of Kafka is actually to not have a downtime, right? Because in general, right, when we had our communication service, there were where you open and you check Kafka at any given point of time, it would be empty, because whenever someone puts anything in down in the Kafka, it will immediately be consumed by the notification service, right? That's kind of the goal of the service, right? Earlier we didn't have Kafka. It would directly hit the notification service. So in a like, the purpose of Kafka is just to be there, right? Just Kafka is the precaution that if someday a lot of services start hitting Kafka, start hitting the notification service, and there's a spike, then the messages get queued up in Kafka, right? And the notification service, it processes it at a given time, and it also starts spinning up new new servers, right? And then the messages keep getting pulled in faster and faster, and that way downtime is, again, I don't see how downtimes happen, right? Hello.
Yeah, I got your point.
Yeah, but again, you have a lot of system downtime due to a lot of things. So but there's one thing, if you notice, right? System downtimes are not that common, right? So if you have a actual downtime, right, out of 10 reasons, 9.99 of those reasons will be some error in the code. It's not going to be DevOps, right? That's how reliable systems are today. That's how accounting is done, because new servers are spun off at 70% literally. Okay, so yeah, I think this went well, right? We did a basic design of Amazon. We discussed all the interview questions that you had, right? So yeah, that's good. Anyone else have any questions or anything to discuss?
Uh, uh, this interview was for like how many years of experience?
Six. Six.
Good. Great. I have 3 years
That,
of experience.
that's a few topics went off my head.
Yeah, yeah. Okay, okay. But yeah, just keep studying. I think you will understand things a bit better, right? Keep practicing. I think we covered most of these topics, right, in the videos that I have. Kafka is covered, Elasticsearch is covered, and I've literally built videos on everything that has been discussed here today. But yeah,
Ramit, what is pen tester? You used a word, right?
yeah,
Pen tester for, I
yeah,
mean, during Kalera.
yeah. So a pen tester is a guy that makes money by hurting companies, kind of. So there are companies that give out these bounties, right? uh, so like, you find a flaw in our software, something somewhere, right, and then you make a lot of money, right? Or so let's just say you have a company A, right, and then there is this pen testers can make money in a lot of way. Their major goal is to find out flaws in the software and exploit those flaws, right? So they can A, get money from bounty from this company, or B, they can be hired by some rival company to do in the company, right? So if a pen tester is going to rack up $1 million bill, um, that's that's a huge loss for the company, right? So a rival company might pay him money, or Kalera themselves might pay him some money, because they are getting the commissions, right? So that's basically what a pen tester is. Yeah. Okay, I think great session so far. So I'll stop recording.